How's it going, everybody? Squeegee Dinotoy here, and today we're going to be taking a look at the fundamental steps of creating our very first map for Skater XL. This guide is going to focus on only the most simple steps required and is oriented towards absolute beginners on the topic. We will use all free programs and absolutely no third-party plugins of any kind beyond the Unity engine that is required for Skater XL maps. If you would like to follow along with a written document, check out the new mapping wiki that I have created. The link will be in the description. To get started, we're going to go ahead and download Unity. The link to this download will be in the description. And I'm simply going to go ahead and click the Download Unity Hub button. Save this, install it, and run it. Once Unity Hub has been installed, we're going to go ahead and need to download a Unity version. In this case, we're going to be using Unity 2019.3.15. This is the recommended build as of the recording date of this video. If the recommended build changes, I'll make sure to adjust the description of the video. It is important that we use the correct Unity version. Once Unity Hub is installed, we can go ahead and click this Download Unity Hub button here, which will download this Unity version into our Unity Hub. Once we've installed the version that we need, as you can see, I have it here in my installs, we can go ahead and create a new project. Navigate to this Projects tab here, and we're going to click this drop down next to New, and we're going to make sure to select the correct version of Unity. We will select this High Definition RP project template here, as High Definition Render Pipeline is what Skater XL uses and what we will need for this process. I'm going to go ahead and rename my project, and it's already in the location that I want it to be at. So we can go ahead and hit create. This will take a minute, so feel free to go grab a drink and be patient while Unity does its thing. Once Unity has completed initializing the project, we can go ahead and take a look at the Unity editor. This is the screen you'll be greeted with upon startup. This here is the HD Render Pipeline wizard, and this is a useful tool to have when creating maps. So I recommend not closing it. Instead, we can simply drag it over here and add it to this side, this panel of our window. If during this process you do accidentally close a tab that you didn't mean to close, so for instance, if I were to close this tab, we can come up here to Window, and we can reopen all of our tabs from here. This particular one is in Render Pipeline, HD Render Pipeline Wizard. Before we get too far into this tutorial, let's go ahead and take a quick look at the Unity Editor window and some of our tabs that we have. Starting up here in the top left is our Tools tab. We have a couple of tools we can use. We use these in our 3D viewport here. If I click to this Scene tab, this is our interactable 3D viewport for our scene. Everything in this window here is represented over here in our hierarchy. The hierarchy is simply a list of game objects that are active in the scene currently. We can click on one of these objects to take a look at it in the inspector. The inspector allows us to take a more detailed look at every object in our scene. Every object is equipped with components. For instance, this directional light has a transform component, a light component, and an HD additional light component. And we can add more components by clicking the Add Component button. Down here in the Project tab, this is essentially our storage area for all of our assets that we can use in our scene. As you can see here, all of the example assets that are used in this example scene are being stored in folders in our assets. We can actually right-click this and go Show in Explorer and view the actual folder layout in our Windows Explorer. A couple of quick tips for navigating this scene view. We can use the middle mouse button to pan around. We can hold Alt and use the left mouse button to rotate. And we can use the scroll wheel to zoom. We can also click the middle mouse to select a new origin point of our orbit. Now that we've gone ahead and covered the absolute basics of using the Unity Editor window, let's go ahead and set up our scene. I'm going to go File, New Scene, and this is the scene we're going to be using for our Skater XL map. A handy tip at the start of the scene is to go ahead and click our main camera object, and we're going to set its tag from main camera to editor only. What this means is the camera will not load in-game once we've compiled the map, and is simply for use previewing our map in the editor. I highly recommend this because it is useful to keep a camera in the scene in the editor for previewing, but if the camera gets compiled into the map, the player's camera will be forced to this camera. The other option is we can simply delete the main camera as well. We can now go ahead and set up our 3D scene for the skater to interact with in-game. I'm going to right click in the hierarchy, go down to 3D object, and we're going to create a plane. This will be the ground asset that our skater will skate along. Note that the plane comes by default with a mesh collider. Colliders are necessary for the skater to interact with in the game. If the collider is disabled, the plane will still be visible, but the skater will fall directly through it as it has no physical boundaries. So we can go ahead and re-enable the mesh collider. And as a demonstration, we could also disable our mesh renderer, and now the object will be invisible, but it will be interactable. But we're going to go ahead and leave it default with both of these enabled, of course, as this is going to be our ground object in the game. The next thing we're going to do is going to right click. We're going to create another 3D object, and this time we're going to create a cube. We can take a look at the transforms for our objects. I like to set everything to 0, 0, 0 when creating a sample scene like this. This allows everything to be centered to the world origin and allows our project to be just that much more organized. The next thing we're going to want is to scale our cube here, which will be our ledge. We're going to want some sort of visual representation of our skater, a scale. In the description, you will see a link to download this low poly Skater XL model. This is what I personally use as a scale reference in our project, as it's the actual Skater XL model, just decimated a little bit to be a lower poly asset. We can just go ahead and drag and drop this into our assets folder. To help keep things organized, I'm going to right click the assets folder. I'm going to create, and I'm going to create a new folder. I'm going to go ahead and call this models. And we can relocate our Skater XL model to the models folder. Now we can simply drag and drop our skater model into the scene. Now it's time to go ahead and scale our box up a little bit to be a normal sized ledge. I'm going to go ahead and position it so that the bottom of it is closer to the ground. And then I'm going to click the Move, Rotate, or Scale tool, which allows us to rotate, scale, and move all in one. And I'm just going to scale this to look more like a ledge. We can reposition it, and now we have a 3D ledge. We can also scale our plane out a little bit, and this time we'll use these scale values to create a larger ground surface. Before moving much further into the project, it's a good idea to go ahead and save. I can right click on the Untitled, Save Scene As, and I can now save my new scene. I'm going to place it in the scenes folder for easy reference and title it. I've now gone ahead and saved my first map scene. Anytime that we make a substantial amount of adjustments, it's a good idea to Control S to save again. Remember, always save regularly as we don't want to lose progress on our project. The next thing we're going to want to do is create a spawn point for our skater. So I can right click in the hierarchy, and this time I'm just going to create an empty object. I can press F2 or come over here to rename it. We're going to want to call it spawn point. This is case sensitive, so make sure that you have the capital P. We're also going to want to give it the spawn point tag. You can find a list of all the tags and layers in the description, and the process for setting these up, although tedious, is quite simple. Go ahead and click on the tag dropdown, add tag, and now we can click the plus and add our first tag. Again, the list will be linked in the description. It's also important while we're doing this to go ahead and set up our layers. We can click this layers dropdown and create the two layers that we need, grindable and coping. Now that we've done that, we can tag our spawn point with the spawn point tag. This allows the game to read it as a spawn point even if we messed up the name. The spawn point determines where the skater will spawn when they first load the map. The blue arrow points towards where they'll be facing. So for instance, the spawn point relocated about here means that the skater would spawn right where the 3D model is of our skater facing the same direction. So I'm just going to go ahead and relocate this so that our skater spawns looking at the ledge. Make sure not to place it too low, as if the skater spawns in the ground, they'll go beneath it. I like to move it up just a little bit so that they drop down to the ground. Now we can move on to creating some grind splines for our ledge. Grind splines are a function that we create in Unity to allow the game to read what is and is not grindable. Grind splines are made up of two core components, the collider and the spline. There are a few variety of techniques to create grind splines. The one we'll be using in this tutorial is the Hondunes method, or the free method, and uses absolutely no third-party tools. This method isn't the most user-friendly compared to some of the other methods, but again, it is free and requires no third-party tools. I recommend checking out my videos on Bill splines or DreamTech splines, or checking the wiki on other methods if you would like to learn more. Our first step is going to create an empty. We're going to call this grinds. This is going to be the parent object of all of our grind splines. I'm going to go ahead and set its position to 0, 0, 0 and leave that alone. Now we can right click on that and create another empty, this time as a child of the grinds. You can see the dropdown will allow us to collapse and expand the children of the grind's parent object. This object is going to be our very first spline. So I'm going to go ahead and position it to align with that edge. A quick tip for this is I can hold V while in the 3D viewport to enable vertex snapping mode and snap it to this corner vertex. And then I can go ahead and reposition it or just leave it there. Either way is fine. The exact position of this doesn't actually matter. To determine that this is a grind spline, we need to name this for the game to read. The naming format is it needs to have the word grind spline in it, and then it also needs to have a grind type. This is what determines the sound of the grind. The 3 grind types we can use are grind metal, grind concrete, and technically the wood tag also works, although it is sort of not really supported anymore. We're going to go ahead and use grind underscore concrete for this particular example. We can also give this grind a name, so I'm just going to go ahead and call it box grind. This is optional, but it helps us keep our project organized. The next thing we're going to do is we're going to create another empty child, and these don't need to be named. These, however, are the points of our grind that determine point A to point B where the skater will be going. This first one can stay on this corner, and then we're going to go ahead and duplicate this object, and we're going to move it to the other corner of the box. The skater now knows that the grind is between these 2 points. Something to keep in mind is that the green arrow represents the normal of the spline. In this case, the green arrow is perfect as it is showing us that the normal is straight up and down. So the skater is being told that the lean of the grind is straight up and down. If we were to have an angled box, we would want to rotate these to match the angle of the grind. So it should always be 90 degrees perpendicular of our grind surface. Next comes the second core component of spline hierarchy, which is the grind collider. We can go ahead and click on our cube here, and we're going to create an empty beneath it. We're going to call this grind collider. The name of this object doesn't matter, but I like to stay organized. It's important to note that we can't just have the box as one big grind collider because we want to be able to ride down the middle of the box without grinding. We only want to be grinding on the 4 edges. Therefore, we will need to create 4 grind colliders and 4 grind splines, one for each edge. To quickly generate an easy box collider in this specific example, we can actually just right click on this box collider component, copy component, go to our grind collider, right click on a component already there, in this case the transform, and paste component as new. We've now copied the box collider from our parent to the child. We can edit the collider by clicking on the Edit Bounding Volume button, which allows us to view the handles. We're going to adjust the grind collider so that it is only on the edge. Don't make it too thin as the skater can clip through, but also don't make it too thick as we only want the skater to be grinding on the edge itself and not too far into the ledge. That's a pretty good looking grind collider. The next step is going to be to go ahead and layer this as grindable. This tells the game that this grind collider is an object that the skater can grind on. And we're done. We've gone ahead and set up our very first grind. We can go ahead and duplicate this process now to set up the other 4 edges. Remember that Control D is your duplicate button, which will allow us to very quickly set up our other grinds by duplicating the work that we've already done and simply changing the values to what they need to be. Just like the colliders, we can duplicate our work with the grind splines. For instance, this one I can simply duplicate and move the whole grind over to that other vertex. We now have all 4 grinds set up. The final step that we can go ahead and do is we can tag our grind colliders with the sound just to make sure that they make the correct sound that we want them to. Okay, so our grindable object has been fully set up. It has its colliders and it has its grinds, all in the appropriate positions. We're now going to go ahead and very briefly touch on setting up some very basic lighting for our scene. This here is our directional light, which is essentially the sun of the scene. The sky and fog volume is the 3D environment that the scene is within. We can actually click on the Game tab to preview what our scene will look like in-game. The default values on these volumes are totally fine, but if we wanted to, we could increase the intensity of our light. It's basically up to your preference how you want to light your scene. A couple of quick things we can add to our sky and fog volume to improve the visuals without doing much work is we can add a couple of new overrides to our volume. I'm going to start with an exposure override. And we can use the game cam to preview how this will look. And by sliding this, we can adjust the exposure override. We can also very quickly add an ambient occlusion to add a little bit of ambient occlusion shadowing in the cracks where two objects are close to each other. The next thing we're going to want to do is add a very simple light probe group. So we can right click in our hierarchy, go down to light, and add a light probe group. Light probes allow us to calculate baked lighting onto dynamic object. For instance, the skater is a dynamic object, while everything in the scene can be marked as static. I've simply just gone ahead and moved my points to the corners of the map for now. If you'd like to learn more about lighting and using light probes, please check the description for more useful links to the wiki and other resources. Now that we've moved our light probes into the positions we want, we can go ahead and mark our two static objects as static. We can mark our skater model as static as well, but we're going to leave him dynamic for the sake of example. So once we've selected these two objects by clicking and holding shift, we can come up here to the top right and click the static box. Go ahead and select yes, change children. What this has done is set everything that we have selected to be baked as a static object. We can now come to our lighting tab. And again, if you don't have this tab, go to Window, Rendering, Lighting Settings. We'll want to apply our profile that we're using. The profile is the asset that determines the values of our sky and fog volume. To see where this is in our project, we can go back to our sky and fog volume and click the profile here. That will take us to it in our project, and we can now drag and drop that asset into the profile input on the lighting settings. Our static lighting sky can be set to HDR sky, as that's what we're using in this case. Finally, we're going to turn our light map resolution down quite a bit. This will simply speed up the bake at the cost of a little bit of quality, which isn't too important, seeing as the scene we're working with is not super high fidelity. This is a useful tip for when you want to do a test bake in the future when you have learned a lot more about lighting. Now we can go ahead and generate lighting. This will take a moment. Once lighting is generated, we'll go ahead and see a very nicely lit scene here in our cam view. And this is what it'll look like in the game. We won't go any more into depth on lighting, and I understand that I breezed past it very quickly in this tutorial. But that's because lighting is a very complex subject, and we'll be trying to cover that in future tutorials and guides. If you had a hard time following along with everything or didn't understand something I did, please check the wiki, where a lot of that stuff is just written down and gone into more depth with. Now that we've set everything up, it's time to compile our map. We can come up here to Window and go to the Package Manager. Give it a second to load in all the packages. And once it's done that, we're going to go to the A section and find the Asset Bundle Browser. Go ahead and install this. We can now go to Window and go to the Asset Bundle Browser. I'm just going to go ahead and relocate this to this tab of my window. Make sure your scene is saved. Navigate to where it is stored in our assets, and we can simply drag and drop this into the Configure panel. The scene is now tagged to build as an asset bundle, and we can very easily inspect everything that's in this bundle. Keep in mind that default shapes like the cube and plane are included in all bundles by default, so it won't show up here in this list. We now go over to the Build tab. The target standalone windows is fine. The output path by default is totally fine, although you can change it if you like to build it somewhere else, like for instance directly to your maps folder, although I don't recommend that in this case. Click the Advanced Settings dropdown, and we're going to change our compression type from lzma to lz4. Chunk-based compression is much faster than the default compression system, but it is also much smaller file size than having no compression at all. It's a middle ground between no compression at all and standard compression, and is highly recommended for all map makers. We can now go ahead and click the Build button. This will take a little bit, especially the first time, so be patient and be willing to go grab another coffee now. Once the project has finished compiling, we can navigate to where it's been saved once again by opening our Assets folder in the Explorer. I remember it's been saved to Asset Bundles, Standalone Windows, and it's called My First Map. We can now just drag this file. Make sure to grab the file that's titled your map name and is type file, not the manifests. It's also going to be the only one that is over 2 kilobytes. We can drag this to our maps folder, and it is now playable in-game. And we now have a skatable map in Skater XL. Before we close out the video, I'd like to show you guys two very quick tips with our maps using the new 1.0 community map menu. First of all, we can actually have the author show up in the menu, as you may have seen with some of the official maps, by just typing by username. The other thing we can do is give it a little preview image in the map selection menu. We can simply take a screenshot of our map. I'm just going to use this one as an example and rename it to the same exact name as the map. So in this case, the PNG will be my first map by username, and that will show up as the preview image for this map. This system also supports JPEGs. Now once we go to the community maps menu and scroll down to our map, we can see the screenshot that I used as my preview image, and we can also see by username there at the top right. Thanks for watching, guys, and I hope that this has been a helpful tutorial for you. We'll go into a lot more depth on the topic and whatnot in the future, but for now I hope that this has gotten you started with the fundamental tools you'll need to create your Skater XL maps. Don't forget to check out the wiki for more information, and check my YouTube channel for other tutorials on other topics. Thanks so much, guys, and have a great day.